Hi everyone, in this video we'll be talking about Azure Container Instance. Last video we talked about Azure Container Registry. Azure Container Instance is a serverless managed compute service that lets you to run Docker containers in cloud. So, what do you mean by serverless managed compute service? That means that we don't have to manage any virtual machines. No virtual machines needs to be managed by us. Everything will be taken care by Azure. So that it offers the fastest and simplest way to run a container. Okay. So Azure Container Instance is a great solution for any scenario that can operate in isolated containers. For example, like simple applications, task automation, and build jobs. It offers you some benefits. That includes one is fast setup. That means you can start containers in seconds and you don't have to manage a virtual machine. Then comes container access. Container access means that Azure Container Instance enables exposing your container groups directly to the internet. This is done using an IP address and a fully qualified domain name, that is FQDN, fully qualified domain name. It also provides hypervisor level security. That means you can isolate your application as if it is completely inside a virtual machine. Then it stores minimum customer data. That the minimum customer data that is required to ensure that your container groups are running as expected. Only that much data needs to be stored for an Azure Container Instance. Then it also gives custom sizes. That means you can specify the exact CPU or memory requirements. It also gives you persistent storage. That means you can mount Azure files and Azure files directly to your container so that you can retrieve and persist a state. Also, it gives Linux and Windows containers using the same API. So now let's understand what are container groups. So container groups, it is the top level resource in an Azure Container Instance. It is a collection of containers that has the same host machine. So containers in a container group share a life cycle, resource, local network, and storage volumes. That means, for example, this is a container group. Okay. You have two ports in it. Let's say this one is port 80. Sorry, let's write it here. And you have another port 500. This will be your first image. And let this be your second image. This can be mounted on a certain list of Azure files. this can be mounted on another list, so that this image can be accessed by port 80 and this one can be accessed by port 5000. This entire setup is called a container group. So in this container group, you can understand that this container group is scheduled in the single host machine, and it is also assigned a DNS name label, and this exposes a single IP address, but it has got two containers in it. One container listens at port 80 and the other one listens at port 5000. Also, it includes two Azure files. So, multi-container groups are currently supported only on Linux. Windows containers only supports single instance. What? Windows. Then let's talk about deployment. There are two common ways to deploy a multi-container group. First one is using a resource management template. And second is by using a YAML file. A resource management template is recommended when you need to deploy more Azure service resources when you deploy the container instance. YAML format is actually more concise in nature. This is recommended if your deployment includes only container instances. That is, if your deployment has only container instances, it is preferable that you use YAML files. But say you have more resources, Azure service resources, then use resource management template, resource manager template. Now let's talk about resource allocation. So an Azure container instance allocates resources like CPU and memory to a container group by adding the resource request in the instance of the group. So if you create a container group with two instances, each requesting one CPU, then the container group is allocated two CPUs. That is, for example, this is your container group and you have got two instances in it. Each of this instance is asking for one CPU each. Then this container group will have two CPUs together in total. Now it comes to networking. So container group share an IP address and a namespace, so that external clients can communicate within the group. So to enable external clients to reach to a container in the group, you must expose the port on the IP address. So the port should be exposed. For example, in this container group, say an external client needs to access this particular container. Then you have to expose the port number in which this particular container is running. This is because containers within a group share a port namespace, but port mapping isn't supported. Containers within a group can reach each other via localhost, so that this container can communicate with the other container using localhost, even if those ports are not exposed. For example, this port is exposed, but this 5000 port is not exposed. Still, this image 1 or container 1 can communicate with container 2 via localhost. Okay. Now let's talk about storage. You can specify external volumes to mount within the container group. So if a container needs to use a storage, it should be mounted to that particular container. You can map those volumes into specific paths within the individual containers in a group. The supported volumes include Azure File Share, Secret, Empty Directory, Cloned GitHub repo. Multi-container groups are useful in cases where you want to divide a single functional task into few container images. So an image might be delivered by different teams and have separate resource requirements. Some examples are like, for example, a container serving a web application and a container pulling the latest content from a source control. This is an example for a multi-container group, or an application container and a logging container. So you can have a resource like container group, and in that you have an application container and another logging container. These can communicate with each other via localhost, and say you expose the port of the application container. Or also you can use a front-end container and a back-end container. The front-end might be serving a web application while the back-end is running a service to retrieve data. Now, let's talk about restart policy. So, restart policy means like specify that like with configurable restart policy, we can specify that our containers are stopped when the process is completed. There are three types of restart policy. First one is always, second one is on failure, and third one is never. So this always is the default setting. That is, the containers in the container group are always restarted. This works for web apps. This means that the container will always be running. On failure, these containers in the container group are restarted if it terminates with a non-zero exit code. These restart policies are applied to those tasks where the task should be executed at least once. So never means that the containers are never restarted. These are used for tasks that should be executed at most once. So even if the task fails, it won't be restarted. How can you specify a restart policy? You can specify a restart policy by using restart policy parameter when you call the Azure container create. Format of Azure container create is like this. Azure container create, then you provide the resource group, my group, then you provide the name of the container. Say name my container. Then you have the image. That will be the my container image. The image, the name of your container image. Then you can specify the restart policy. Here you can provide always, on failure, or never. Let's give on failure. If you don't give this particular parameter, then the restart policy will be always. So Azure Container Instance starts the container and then stops it when its application or script exists. When Azure Container Instance stops a container whose restart policy is never or on failure, then the container status is set to be terminated. So if it is on failure or never, and if the container is stopped, then its status will be terminated. If it is always, then what happens is that the container is restarted again. Then you can set environment variables. So setting environment variables in your container instance allows you to provide dynamic configuration of the application. So these environment variables are similar to the environment command line argument that is given to docker run command. For example, these are provided within the Azure Container Create command. Like this, we can give environment variable, and you can give a variable and equal to a number like 5. Okay. Now you have something called secure value. Secure values are intended to hold sensitive information, for example, like passwords or keys to your application. So environment variables with secure values will not be visible in your container properties, and they can be accessed only from within the container. We set a secure environment variable by specifying the secure value property. For example, you will be, let's say you have got a YAML file, and in that you have the environment variables. And in that you have the name. If it is not a secure value, you just provide the name and then provide value. But if it is like a secret, you have the name, and instead of value, you will be giving secure value. My secret. Okay. Also, you can execute this particular container or create this container by using the Azure command like Azure Container Create. You can specify the resource group, my group. My group, and then you can specify the file. Let's say you have saved this particular file. Well, there are data, like things are required below and above this particular thing. So you just have to specify the name of the YAML file, .yaml. Next is how to mount an Azure file share in Azure Container Instance. So by default, Azure container instances are stateless. So that if the container crash or stop, all of its state is lost. To persist state beyond the lifetime of a container, you should mount a volume. This is mounted from an external store. Azure Files offers fully managed file shares in cloud that are accessible via SMB or Server Message Block Protocol. So using an Azure file share with Azure container instances provide file sharing features similar to using an Azure file share with Azure Virtual Machine. But there are certain limitations to Azure file share. The first one is that you can only mount Azure files shares to Linux containers. Also, Azure file share volume mount requires a Linux container run as root. You need a Linux container run as root. And also, Azure file share volume mounts are limited to CIFS support. You can deploy a container and mount volume using like Azure file volume account name, account key, share name, and mount path. You also need to provide a DNS name label. This DNS name label should be unique within an Azure region. So update the value in the preceding command if you receive a DNS name label error message when you execute the command. Okay. You can also mount multiple volumes. This can be specified in the YAML file in the volumes section. So you can specify these volumes as a list of objects. Okay. So this is all about Azure Container Instance. Thanks for watching.